Let me just test this mic. 1 Bitcoin worth 1 million. Good. 1 Bitcoin, 2 million. 1 Bitcoin, 3 million. Good, good. Oh, good. OK, so we have this thing working. So the problem for 1 Bitcoin worth 1 million is actually not too many people on the street using blockchain technology. We're kind of like running this small Hogwarts school that we think we're playing magic, but in the real world, people are not really using blockchains. So the problem is like how we're going to using Bitcoin, how we're going to using blockchain for day-to-day. OK, so 1 Bitcoin, 1 million. we need slides. Oh, OK, so let's see. OK, good, good. So the problem is how we're going to use blockchain technology for a day-to-day application, rather than just use that for speculating some kind of assets. So that's the big problem for us to reaching Bitcoin was 1 million. And the second problem for the people on the street is their applications very much tying to the servers. So the problem for tying to servers, basically you're paying too much commission fee, and you're basically under control of the big tech, and there are many, many problems. So given that, we actually think of a new idea. This is a new consensus called perishable proof of transaction. So this is a completely new idea. Basically, the most important block in the Bitcoin ledger is the Genesis block. So we're kind of challenging the idea. So if we can get rid of Genesis block, make the blockchain completely small, and this may give something very different. So I would like to take a technical discussion, a technical journey, and to look at these new ideas. So first, we have this thing called Immutable Blockchain, which is Bitcoin, Ethereum, ADA, and the wonderful stuff. I have nothing problem with that. So basically, they require the community members to remember the full history collectively. So there's a lot of burden for nodes to remember the whole state space and the whole ledger. But it's very good for long-term financial contracts. Like it's good for NFT, good for smart contracts, good for DeFi, and good for many, many things. But this is only a small part of the real world we have. And the burden for ever-increasing state size already become a problem for Ethereum. We're talking about 4 terabyte hashing map for the Merkle-Patricia tree. And in the Bitcoin, the UTXO is just too big to manage. Some of the Bitcoins are locked into UTXO. We cannot just get them out because it's just too big to store for many nodes. So now we're kind of thinking, basically, so I'm a technical person, so I talked to my team. We tried everything, tried to scale up a Bitcoin, but nothing worked. Everything failed. So then we come back to say, let's challenge something very, very basic. How about we make a blockchain completely perishable? So which means a history beyond a certain time frame, such as 6 months, will be completely forgotten, will be ignored. It's a completely crazy idea. So we start this idea, and suddenly we're entering into this gate. There are a lot of magics happen to us. It's suddenly opened a different world for our imagination. So first, only accounts with a transaction in past 6 months will be valid. So transaction beyond 6 months will be completely forgotten. It's probably very bad for regulators. So nothing going to be. It's like Snapchat. You cannot use that proof anything for regulators. So maybe not good. And also, basically the blockchain is used to recording the metadata. So what are the metadata? It's basically your address and your balance. Those are very important informations. Because with the address, we can achieve something called a key-to-key communication, not account-to-account communication. So with key-to-key communication, it's much cheaper and much more independent because you can generate your key easily. And you can get other people's key, just like, say, sending me your public key, and I can send message to you. And because it's perishable, it demands a very low computing resource. So one ledger will be able to manage that under 50 megabytes. So a modern phone can easily handle 100 blockchain as a full nodes. So this is something very amazing because these days the wallet, none of the wallets are decentralized because the wallets basically have to connect in some kind of server. Even wonderful MetaMask, I like that, but you still have to connect in some kind of nodes. You cannot just run a transaction by yourself. So given the computing resource is small, a phone be able to manage become full nodes. So the communication speed is no longer restrained by how good you're connecting to server, but only restrained by your ability of the bandwidth. So we pay particular attention to save bandwidth because Africa market is our design background. We think if this application doesn't work in Africa, it wouldn't be a good technology. No, again, if it works there, it will be excellent here. So we're kind of using Africa background to decide that. That's actually gives us some very good finding, because we found that the IPv6 protocol is so much available in Africa that they don't really have this much NAT issue. So that's very going to be another topic. We're getting very excited about that. So the design goal is like we want to have a small community to run their own coins. So for example, like Africa again. So if we go to Africa, there's no servers and too expensive, and most people cannot afford Bitcoin, Ethereum, all those kind of wonderful coins to run their tokens. But you have friends, you have phones. So as long as you have friends and phones, you can using Perishable blockchain to build your own small coin community. You can circulate in your stable Noodle coin, like coin get Noodle. You can circulating a whatever membership you want to do that. So that's the benefits Perishable can bring to us. Okay, so the design goal is for day-to-day application for small communities. So let's get a little bit technical. PPOT, Perishable Proof of Transaction. Thanks to NXT, so I really like that white paper. So the basically like 7 years ago, unknown guy, anonymous again. So this guy wrote this white paper. I hope he's here. So really thanks to him. NXT white paper laid down this concept called the generation signature. It's technology of a network randomness to achieve consensus by using stake. I think that's a very early stage proof of stake consensus. Basically, the more stake you're holding, the more probability you can generate next block, so to win the reward. So, but there's a problem, because network generation, generation signature can predict what's the future address has higher probability to receive block. So they're able to moving stake from address to kind of getting more favored, more favored to winning next block. So we're kind of changing ideas. Okay, if we're using transaction history as the weight, as the difficulty, you cannot really moving transaction, because transaction happens on address. So we're changing the POS to POT, proof of transaction. So by doing that, the security level increase. So the reason most of the consensus don't using POT, because it's not good, right? It's not good, but because people like the coins value go up, and you really want people holding more coins, so actually the value goes up. So we're taking a different perspective. We want to have the chains to be more active. So the more transaction you're making in the ledger, the more probability you will win next block. Okay. But the problem for POT is someone might accumulate huge amount of power and control the network. So here comes the perishable. Because every 6 months, your transaction will be forgotten. So no one is able to just have the huge amount of power for a very, very long time. So somehow these things all fitting together. So we have a problem with the proof of stake. We have the power shifting attack. Then we're converting that to POT. Then plus in perishable. Then PPOT become this final piece. Honestly, we only figured this out literally like 6 months ago, after 2 years research of scaling Bitcoin and trying different things. We just built everything and built on the relics. We found this PPOT. We feel very, very lucky. And we actually focused on this original principle called permissionless and non-delegates. I know a lot of people don't like non-delegates. It's a very, very difficult concept to swallow. Because ledger is so big, the state is so huge, you have to give data availability or transaction execution to some supernodes. But in the perishable world, there's no discrimination between supernodes and a wallet. Everyone's the same. 50 megabyte, you can have the whole node. So it doesn't matter how big server farm you have, you will end up the same as the wallet. So there's only one role. And permissionless. So permissionless means the design purpose of Tau is all about you don't need to own Tau coins at all. Because we think any ownership of a certain coin is an infliction. It's just too expensive. And if it's not expensive today, it will get expensive tomorrow, like Ethereum. So it has to be permissionless. So that's why we built our protocol without having to own Tau coin at all. This is a protocol and open source and free for every community. You can just run your things without owning any specific coins. I think, again, it's very good for Africa Village. They cannot buy any specific coins, basically, because the bank, no bank account there. So just want to emphasize holding a shorter history and the phone just getting released. And believe it or not, the phone these days become very powerful. Most of the phone having like half gig storage, so can basically become a full node for literally 100 full blockchains. OK, so this one I want to emphasize is a little bit technical. So transaction pool is converting to communication pool. So this is actually how we're actually increasing the communication speed. In the Tau world, there's no difference between messaging and the transaction, which is not possible in Bitcoin. Because when you, let's say, when you play Tinder, I send 100 messages out, and 99 said no. So those information cannot be stored on permanently. I don't like that. So it should be perishable. So on the traditional blockchain, so because there's no messaging, you have to store everything on chain, which becomes a burden. But in our case, because it's perishable, so everything is a transaction. And because every node becomes full node, you can have your own transaction pool. For people building nodes, you understand. For wallets, there's no way to own a transaction pool. Transaction pool is owned by this holy grail node. They have the privilege of doing that. So now every node has a transaction pool. Everyone be able to communicate. So that's how we're actually achieving this higher speed of a communication. So now every participant has a pool now. Networking. OK, so the consensus part is actually very easy. It's very easy to understand than any kind of ZK stuff. But the most difficult part is networking. The consensus is very easy to implement. So networking is difficult. I'll give you an example. So for the Bitcoin world, I think we'll probably just only have 100 full nodes. The server farm is huge, but only 100 full nodes. The communication complexity is n squared. So 100 n squared, no big deal. We can gossiping. So the gossiping protocol works well when nodes number are small. Ethereum probably effective nodes 1,000. 1,000 squared, OK, manageable. But for serverless, perishable nodes, every phone become a node, we easily we can get 1 million. So 1 million squared, how do you deal with that? How can people communicate to each other with this so much complexity of networking? So this is actually we learned so much from Torrent. So thanks to Arvin, he built this wonderful libTorrent protocol. The more we dig into it, we just find this is like a god, you know. So he comes to this idea called a choke, the choking mechanism. So the choking mechanism said, it's like coming from this called a prisoner dilemma. You put two bad guys into jail, and they have to talk honestly. Otherwise, one guy will be punished. But they're always bad guys. OK, one guy says, I'm going to tell the lie. I'm going to get out of jail. And I'm happy. So now they engage this thing called indefinite prisoner of dilemma. OK, that's a choking mechanism. It's indefinite prisoner. Because you even get out of jail, you come back tomorrow. And you lie, yes, you get out, you come back tomorrow. So in that situation, everyone will realize that the best way is really to tell the truth, like contributing data. So the choke mechanism basically said, for a particular time slot, very short time slot, only two nodes can communicate with each other. If you're lying, you're not providing data, you'll be punished right away. Even if you don't get punished today, you'll be punished tomorrow because it's indefinite. So the choking mechanism really makes the torrent world so robust. You'll be able to download the movies and all those sort of things without problem, thanks to this choking mechanism. So we use the same idea to managing the networking situation. But there's a lot of coding to write and a lot of testing to do. So this is actually a difficult thing to do. So that's one way of incentivizing people, say, telling truth and sharing data. And the second thing, so like in the real world, I want, for example, make this gentleman do something for me. The first thing I will try, I'm going to threat you. I'm going to scare you. All right, you're a brave guy, I don't care. Then the second thing I'm going to do, I'm going to give you some benefit. You may do it. Either or, you will do something for me, right? OK. So the second approach is, this is actually using by DHT. It's like, okay, my name is David. If another guy called Daniel, he comes out and says, OK, I want to share a data with you. Because we share a very similar name, we belong to the same tribe, I will give you more favor. I will give you more data. Like, probably you're my neighbor. So in return, next time, when you relay data back to me, because we're a similar name, you give it back to us. So this is like a prefix peers. So we're using two methods to encouraging data sharing, even in a very big, complex network. So I can go down to a lot of details onto the thing, but this is very exciting stuff, the networking. And the second thing is, because on the phone network, there's no stable connections. So any protocol we have like TCP, UTP, or Quick, and those kind of connection-based protocol wouldn't work because the phone is behind firewall, on and off in a second. So there's no continuous stream. This kind of nightmare. How are we going to deal with this? then we come up with this idea called UDP with Levenstein Distance. So Levenstein Distance is something that you have when you're editing the world, you type a wrong word, the editor will give you an option of a new word. So the concept calculating the distance between two words and give you the correct one. So the Levenstein distance is like, OK, we allow one node to sending data regardless to the other side. And by the same time, we're sending this Levenstein distance, which is a very small value, very, very small. And the receiver will compare these two things. And by the end of the day, they'll be able to have the whole stream. And Levenstein distance is better than Bloom filter, if anyone using Bloom filter, because Bloom filter doesn't have a sequence. Levenstein distance has a sequence. So with sequence, you have a small footprint of data. You'll be able to communicate more missing information to the receiver. Then by exchanging Levenstein distance, very quickly, the data can be uniform. So then the length of a Levenstein distance determines how fast you can get the outside data. So we'll kind of experiment that. So we think for for phone swarm, so this kind of approach is better than TCP, better than UTP. I'm sorry, not UTP, better than UTP, and better than those connection-based communication. And we have a little thing about live signal to maintain swarm stability, because every phone, when you're switching cells, your IP address change, your situation change. So we have this live signal. It's a mutable data item, keep your nodes live to be able to receive and sending communication. So there are a lot of work in the networking to make this thing happen. OK, so finally, I want to talk about some attackers, because I really enjoy talking about how people attacking us and how we defend, and this kind of getting very technical. So first, very famous secret chain attack. The secret chain attack is a general attacking mechanism, including double spending, nothing at stake, history reorganization. So those kind of attack is talking about one supernode, they'll be able to mining behind the scene and generating a chain. And after they're spending some money on the other chain, then they suddenly give you the chain that they sort of getting money back. And also, one powerful node, they can recreate an entire history, and community get confused. Same thing, nothing at stake. So it's a very difficult thing to deal with. So in our world, we create this concept called the consensus point. It's not an epoch, not a checkpoint. It's because all the nodes are able to vote. Because every node is a full node, they're able to vote. So we'll keep on collecting the consensus point. Because when the community are observing a chain, it's very difficult. It's harder to holding a secret chain without to be found by the community. So whatever happened prior to the consensus point will be taken as a genesis. Whatever happened prior to consensus point will be taken as a genesis. This actually makes computing so much faster. You don't have to compute from the first block all the way to today. So consensus point, as long as it get reached, as long as it getting consensus reached, sorry, my English, reached, and everything prior to that become genesis point, genesis block. So we hope that can fix the problem. Certainly, it's much safer than just having. It's much safer in an environment that people are not be able to voting. So that's how we deal with the POS secret chain attack. And the state shifting attack. State shifting attack is talking about you can predict in the future. Then you move your state over to the future. Then you capture that block over there. So we replace that with a transaction history. There's no way you can move the future. No way you can move your history, because history is fixed to address. And because of that, we don't have to deal with BFT type of things. It's a little bit too generalized. I think every delegation mode is a type of a BFT, which is wrong. But I'm just making it simple. So any type of delegation is kind of a BFT. So with everyone be able to vote, we don't have to go into that route, having delegates. So that thanks to this distributed denial of service. Distributed denial of service. Because it's a swarm, it's no longer become a set of nodes. We don't really have a single point of failure. It's a swarm. It's very difficult to attack a swarm. You have a mosquito there, you just cannot shut them down. It's always there. So naturally, a phone swarm is resistant to denial of service. And there's some little interesting things we found out. Because we're afraid of the control of the blockchain, so in case of the worst scenario happens, someone control the blockchain, what do? So we invented this thing called negative block numbers. So in the mathematical field, when you're inventing something negative, or going to imaginary field, there's some magic will happen. Assume their blockchain is very, very bad, nobody like it. So you as a community leader, you want to take a rebellion out of it. So then we allow you to create this negative blockchain number. You don't have to wait block to happen. Like every 5 minutes a block, if you go to negative, you can just take off a whole chain and put it into negative block. Then suddenly, the whole community being created with a negative history. Because 6 months, you're starting from 0, everything like 50,000 negative blocks will become instant valid. Then you just announce that, okay, I'm rebelling. I'm a rebellion from Tao. Tao is very bad. I'm rebelling. And I created the next chain. And suddenly, the community can shift out. So when people are doing airdropping, the biggest problem is like the fee for paying for the airdropping tokens. So because of negative blocks, those can be avoided. So we're encouraging rebellion. Transaction pool is manageable. I think I have explained that. And the final point, I'm not going to keep you long. So the final point is the whole design purpose is you don't need Tao. You don't need Tao coins. That's inflation. So without owning a specific coin, you basically let your community fly. They can do whatever they want and without purchasing and buying your things. We have lots of documentations and content on our websites. And if you guys are interested, you can read that. And I have a video to summarize everything. So if the gentleman behind the stage can play the video.
Hi, I am Tower Crypto Phone Mining. Crypto phone mining aims to enable one phone to independently mine and operate in 100+ community blockchains. It does not require assistance from central servers.
Yeah, music.
The app and API is developed by Tao in Cambridge Science Park, UK. The innovation is perishable proof of transaction, PPOT, consensus. The blocks older than 6 months will be forgotten. In return for full phone node to achieve high communication throughput. Choked voting to resist secret chain attack.
Thank you all.